because this first page we're going to go a little quickly because we should already know majority of these at least from last year. So when we're talking about products of powers, okay, remember our power are just the exponents. If they have the same base, like the x is here, what do we do with the exponents when we multiply? We add them. Okay, so we are going to write out our rule really quick to make sure that we have those down. Let's see how I want to write that out. Okay, we have a to the m times a to the n equals a to the m plus n. Okay, that's the rule. A is your base. Nice and simple. We're adding the exponents. That's all we're doing. Interesting. Okay, so when we look back on this very first example, what is our final answer when we multiply these? Boom, done. Okay, now I'm going to do the first one with you here, and then you can do the next one with me, or with yourselves and with your group. Okay, when we have fractions, a lot of you get intimidated by them, but please don't, especially when we have the same base. Okay, when we have the same base here in our fraction, or the same denominator, I should say, all we have to do is add the tops. But what do we do with the bottoms? We keep them the same. Okay, so I have x to the what? Because what's 5? Yeah, 8 divided by 4, which then is 2. Awesome. So please do the next one. You do simplify. You're correct. Well, let them do it. They got it. Okay, this one, you add the tops, you add the numerators, and you get 4 halves, but we know that's to the square, squared. But what is 5 squared? And we're done with that one. Okay, I'm going to pause right there for 5 seconds and ask, do you have any questions on what we just did? Because hopefully that's review. Okay. All right, moving on, because now it's basically the same. But we're dividing, and when we divide, what do? We subtract them now. So I have a to the m times a to the n equal, oh, whoa, not times. What am I doing, Miss Sabo? Come on now. All right, divided by a to the n equals a to the m minus n. Okay, I know it's like weird letters. It's just to help you see something. Okay, all you're doing, if you have the same base, you subtract exponents. That's just the rule. So that if you had questions, you can go back and say, okay, that's what they did. They just subtracted here. So let's do this one first. Okay, this 12, it only applies to the x. It does not apply to the 9. So let's first talk about our numbers. What can I reduce 9 and 18 to? 1/2. Okay, I really don't need to write that 1 on top. If you want to, you can. Now, what do I do with those exponents again? I subtract them, so I'm left with what? X to the 9th power. Very good. Okay, so remember, all we did, 12 minus 3 is 9. Okay? What if the 12 was on the bottom and the 3 was on the top? Very good. So the x to the 9th would go to the bottom because it would stay down there. Wherever the bigger exponent is where it belongs. Okay? So let's actually do some examples here. Here we don't have common denominators, so it's not as fun as the last one was. However, we can probably get common denominators pretty quickly here. Yeah, you want to times it by 2 in order to go ahead and get a common denominator. Because now I have x to the 3/4, x to the 2/4. Very good. So then all I do is subtract them. What am I left with when I subtract it? What am I left when I subtract my exponents? Yeah, x to the 1/4 on the top. Very good. Go ahead and try this other one, which should be even easier because it already has common denominators. When you're done and when you're done only, look up. You can write the 1 if you really want, but 5 the first power is just 5. Do you have questions on these two? Because those I feel like should be second nature at this point from last year.
Don't the fives cancel out?
Fives, that's a good question. These are bases. They have exponents. You can't cancel them out unless it was just 5 over 5. Because they have exponents, you have to do that subtraction. Yes. It's actually very common. People do that all the time. Now let's go to these. A power to a power. Do you remember what we did when we had a power to a power? Multiply. Very good. We distribute that 5 into the cube. So I'm going to distribute it in just to the exponent, not to any kind of, if I had like a 3 here, it wouldn't be 3 times 5. Okay? It actually would be 3 to the 5th. But so that I would have x to the what power?
15.
Boom. So let's go ahead and write up a rule for this. A to the m. Good. So then we're going to multiply them. So a to the m times n. Okay, that's just a rule for you to look back on. A being your base, m being your exponent, and also being an exponent here. We're going to distribute it in. Okay. Let's go ahead and take a look at this next one. All I'm doing is distributing just to that exponent. So I get x to the 6 over 2. Sorry if mine don't look like exponents. I should probably make it a little smaller. X to the 3rd. There we go. Do you have questions on that part? Yes.
So you only multiply by the numerator?
Yes, because technically this is 6 over 1.
Okay.
So 6 times 1 is 6, and then 1 times 2 is 2. Yeah. Okay, go ahead and try this next one. Well, let everyone give it a try. Let everyone take a second. Okay. All right, looks like we're ready to go. Here is a very common error. Very common, we see it all the time. When you distribute the 2 in, it's very common that some people will distribute to the denominator as well. You're just distributing to the numerator, and here's why. Because technically this is over 1. And when you multiply fractions, you multiply straight across. So 5 times 2 is 10, and 2 times 1 is 2. Now, do we know 3 to the 5th? Maybe not in your head, but does your calculator know 3 to the 5th at least? What is it?
8. Wait, no. 125.
Thank you, 243. I would say, here's my dilemma with that, logically, just saying, when you have a 3 as a base, you're never going to multiply to get 5, ever. Like 3 times 3 is 9. It's okay, but I was trying to see how you can logically think in your head that wouldn't make sense, that's all. Thank you for trying, though. All right, now let's look at the next one. All right, we have a product to a power again, but now we have more than 1. Now, a lot of people, I'm telling you, we see this all the time. A lot of people think, oh, 4 times 2, 8. But it's not 4 times 2, what is it?
4 times 8.
4 squared. Okay, so this technically has a 1 right there. So if you forget that, make sure you mark that down. So when I distribute it in, I have 4 squared, and then x to the 16th. Yep, so then we have 16, x to the 16th. All right, so when we have this rule, again, it's the same exact thing. So I'm just going to go ahead and draw an arrow because it's the same exact rule. I want you to go ahead. No, I'll do the first one with you. All right. So remember, there's an imaginary 1 here. I'm going to distribute it in. I get 64 to the 1/3, x to the 6/3, and y 7/3. Remember, I'm going to make sure that you understand this. Some people are not. You only multiply the numerators when you're multiplying. Now, if I had this, for example, let's just say I had this. Pretend with me. Don't write this down. If I put a 2 here, yes, it would be 7/6 because you multiply straight across. Okay, but I don't have a 2 there. I just have a 7, and that's only in the numerator. Now, there are a few things we can simplify. Now, does anyone remember, just out of nowhere here, let's see if you guys can remember this. Does anyone know what 1/3 really is? It is 4, but how did you get 4?
Well, because when you, it's like, if it's a fraction, when you just multiply it by
Not multiply by, the 4 is correct. Does anyone know what this really represents?
Yeah.
0.3333.
Yes, technically, you're correct.
1 piece of a 3-piece pie.
Yes. Okay, so let me explain to you just, again, we're going to get into this in a second if you were to look on the next page. But 1/3 really means the cube root. That's what that means. Just like 1/2 really means the square root. Okay, and the cube root of 64 is 4. Or you can get out that thing that we call a very awesome technology that was given to you. It's called a calculator. You could put in 64 to the 1/3 and you would also get 4. I will say if you don't have a fancy calculator that automatically puts the fractions in, you must use parentheses. So 64 caret.
Is
Parent.
4 cubed 64, right?
Yep. Isn't that cool? Awesome. So then I have x to the what then?
2.
And then y to the 7/3 because I can't do anything. Try the next piece, please. Yeah, you could just type in your calculator, but that's something that might be on, yeah, that might be something that might be on the SAT.
I can see you can do it from
All right, a lot of you said, hey, you just type the whole thing in your calculator because they're all numbers. Fine. But this is probably something that you would see on the SAT that was a non-calculated question. Okay, because it would be expected for you to be able to know that. So hopefully by the end of this chapter, you get better at it and you wouldn't really need one for this. So this would technically be 16 to the 1/2 times 9 to the 1/2.
Which is 4 times 3.
Which is 4 times 3, which is 12. Very good. Because to the 1/2 power really means the square root. That's really what that means. We're going to get more into that on the next page. What 1/2 really means is the square root, and the square root of 16 is 4, and the square root of 9 is 3, and 4 times 3 is 12. Cool? Okay. Next one here. Now we have a quotient to the power. It is the same thing. Just make sure that you apply that exponent to all of the pieces of the quotient. I'm going to apply the 2 to here, and I'm going to apply it to here. Okay, so whenever you have a piece of something, just like we did above, you need to apply that exponent to it. Remember that this 7 has an imaginary 1. So I have 7 squared, good, over x to the 8th. All you're doing is you're multiplying just the exponents. Please don't multiply 2 times 7. It's not 14. Because what really is 7 squared? 49 over x to the 8th power. Okay, so we're just going to do again another basic rule. If I have my base to the n over my base to the m, what is it? What's the next one? Maybe this is a good letter here. Let's just put x. Then you're just going to multiply it in. So I would have a to the nx over a to the m times x. Okay, that's just a basic rule for you to be able to see. Okay, they could be different bases. It doesn't necessarily have to have the same base, but at least you understand that that is what that a is representing, is a base. Okay, so now let's take a look here. Let's see if you if anyone recalled what I said a little bit earlier, has a little bit of retention here. What does this 1/3 technically mean? Yes, okay, oh my God, you are geniuses, all of you. You're already learning. Okay, because really this means, 27 to the 1/3 all over 64 to the 1/3.
Which is 3/4.
Yes, because what Mike told us was, hey, it's the cube root. Well, the cube root of 27 is technically 3, and the cube root of 64 is 4. Now, you could have just gone into your beautiful calculator. If you really got stuck with those fractions and just didn't know that, you could have just typed that in. And that's okay. But like I said on the SAT, this would probably be something that they would ask you or would expect of you to know with a non-calculator portion. Yes. Oh, I thought that was a hand. Does anyone know what anything to the 0 power is?
1.
1. Yeah. Right now, if you typed in for the 0 power in your calculator, you would see that it is 1. So all we're going to do is say our base to the 0 power is going to equal 1. So guess what both of these answers are going to be? 1. But I have to ask you a question. Did I make an error?
Yeah.
Where did I make an error at?
The second exam.
Not the second one, but there is something. Do you notice how this 0 is only applied to the x? So this 5 is still there. So Miss Abel made an error here. Yeah, so it is 5, because technically it's 5 times 1, which is 5. Here the 0 went to all of them. It went to every single one of those. So I made an error on the first one. So make sure that you see where that 0 is going to. Okay, because it's, I did. No, I made a mistake. I didn't realize it. I was trying to zoom by, and I just totally made an error. That's why we can't zoom by sometimes.
Zoom by.
All right, let's keep going. Whenever we have a negative exponent, does anyone remember what we do with them? This one's a little tougher than the other ones. Yeah. What'd you say? Only when you have a fraction, you're going to have a root. Yeah, okay, we got someone that remembered from last year, so good job. Okay? It was Katie, because she remembered. It's awesome. She should get recognized for it. Okay, so this negative means that all we're doing is bringing it to the opposite position. So, what does that mean? It's currently on the top of the fraction. If there's a negative, it goes to the bottom of the fraction. So I have 1 over x to the 4th. Okay, it just goes to the opposite position. It wasn't the top, it went to the bottom, and that's it.
Can you explain that again?
Yes, so whenever you have a negative exponent, like -4, okay, that negative is telling you that it's really actually in the denominator. Okay, so you're able just to move it down. So that's why I took x to the -4th and brought it to the denominator. When I bring it to the denominator, I have to put the 1 on top because there's nothing else up there. Now, for example, let's just say I had a 3 here. It would be 3 over x to the 4th, for example. Okay, but let's do a little power rule here. Okay, if I have a to the negative n, I'm then going to have 1 to the an.
What if the negative exponent was in the denominator?
It goes to the numerator.
It
Boom.
goes to the numerator.
Now let's actually do this. Let's give it a try. It is currently where? So where does it now need to go? The denominator. So I have 1, because there's nothing else by it. It's not like I have another 5 somewhere randomly. To the 36 to the 1/2 power. What does that half mean again? And what is the square root of 36? Oh my God. It's like I'm teaching geniuses every day. It's insane. All right, go ahead and do the next one. It's currently somewhere. Where are you going to put it down?
You're gonna put it in the numerator,
You are going to put it in there.
which makes it 27 over 1, which is 3.
Only when you're done, look up. Do not look up until you've completed it. Okay, good. Do you have any questions on that part? Please don't be shy. I'll give you a second to make sure it's all written down. I'll give you another 30 seconds to make sure it's all good. We got one more in the back. So it's part of the solution. You have to keep the base with it. Yeah, so like, technically that exponent is like attached to 27. You can't just separate them. Yeah. Yeah. Good. All right, here we go. We're only going to do a couple of these. I need to do what for letter A? Yes, I need to find the common denominator because what am I doing with the exponents? I'm going to add them. They have the same base, so I'm good. Make sure that you're looking for that. Because if I put a 5 to the 5/6 power, you can't do anything because they're not the same base. Okay? So I'm going to have 12 to something, but what's my common denominator? 24. So what am I going to multiply the top and bottom by for this first one? By 3. What am I going to multiply the second one by? By 4. Because I need a common denominator in order to add fractions. So I have 12 to the what?
23 over 24.
And then I have times to the what?
Wait.
Did I mess up?
No, you're good.
Okay.
They want you
You
to
don't
the
do
answer.
Oh, you're shooting to the answer on me, are you?
Yeah.
Because you guys are too fast for me.
Yes.
Now, remember, you add exponents now. 20 plus 3 is 23. If you ever get stuck with fractions, just type it into your calculator. It'll do it for you. As long as you know how to manipulate the calculator, you'll be fine. Okay, let's look at the next one. Yeah, so technically this needs to go into the denominator. There are more than one way to do this. There's more than one.
There's more than one way to do this.
Okay, I said it right because sometimes my English is not the best. That's why I teach numbers. Okay, so there's a few ways you can do this. First way, some people are like, I want to distribute both first. Someone just said that they wanted to bring everything to the bottom first. It doesn't matter. Okay, you can do either or. Does not matter. So someone said they wanted to bring it all to the bottom first, so that's what we're going to do. I have 1 over 2 to 6 times 4 to the 6, all now to the positive 1/6. That's what someone wanted to do, and that's totally fine. You could have distributed in first. You would get the same answer as us. Okay, see if you can go from here. You got this, because you just need to distribute the exponents. But I think you were gone when we did that. Maybe Katie can teach you now, because maybe she's got it now. You don't think so? It looks like you're getting it, so I can keep going. I have 2 to the first power because 6 divided by 6 is 1. Then I have times 4 to the 1 power 2 because 6 divided by 6 is 1, which then gets me 1 over 8. Okay, there you go. We'll have to make sure that you know how to. This one's challenging and we need to do it. Okay, this one is challenging, but we got it. When we see this division sign here in blue, what do we have to do with the exponents? Subtract them. Very good. This technically has a 1, so be careful. So I technically have, we're going to take it piece by piece here. I'm going to highlight just this piece. I have 10 to the 1 minus 2/5. Just kind of having you visualize what's going on here. You're subtracting the exponents. I'm just going to write them all out first. And then I have this guy in blue. What am I going to do here? X to the what? 1 minus. Very good. I'm just going to write them all out just so you can see them. Maybe some of you are quicker than others and will be able to do it faster, but I'm going to write it all out for the first round. Then I have this guy in yellow. How am I going to write that one out? Yeah, it's the 1/2 minus 3/4. I know it's not fun. It looks weird. Like, whoa, what's going on? You're just working in the exponents. Forget about the bases for a second. Okay? What is 1 minus 2/3? You can either put in your calculator or you can do the math. Oh, sorry. 2/5. I can't even read my own handwriting.
That's our answer.
2 or 5 is what that's supposed to say. Yeah, very good. So I have 10 to the 3/5. Because what technically is 1 when we rewrite it as 5?
1 over 1.
Well, we need 5 though.
5 over 5.
5 over 5. 5 minus 2 is
That's where I went.
boom. Okay? 1 should be easy to work with because you really technically just keep whatever that common denominator is and put it over there. So I have x to the 1 minus 3. What do you get? Yeah. So I like how she said that. Oh, a couple people said, oh, it's -2. You're correct. Or you could just recognize because it's -2, where does it go?
On the bottom.
On the bottom. So I have x squared. One minus 3. Now, here, what did you guys get when you subtract these? -1/4. So where's it going to go? In the bottom. Okay. D is probably the funnest one. When you see it, you'd be like super excited because it's very easy. It's all raised to the -1. So really what just happens to the fraction?
Flips.
It flips. Okay, go to the next page.
Wait, why was it the beginning?
We don't need to do E, it's fine.
So make sure you have plenty of time to do your homework, and E is similar to C. Just one of them more separate.
This page is fast. We have this radical sign. Okay, so this is called a radical. Okay, this is our index. Oh, no, it's not. This is our index, is what we call it. So, I can't spell either.
There's nothing there, it's a 1.
No, it is not.
It says 0.
When I say the square root, it's a 2, okay? Okay, and then this is actually called, what this is inside, this radicand. You don't really need to memorize these words, but if I say them or Ms. Markowitz says them, you need to be able to tell what we're talking about. If I say, what's the index, you should be looking for that little number that goes inside. Okay, if I say radical, you should know that that's a little house thing. Okay, so there are some properties of radicals which are off to the right. When you're multiplying them, you can just multiply them inside, and then also with dividing them. When you're talking about rewriting them in different ways. So we just talked about this in the last page, so hopefully you're prepared for this page and it'll fly by. I told you that, we'll start from here. In the last page, I told you a to the m to the n. Remember I said, what's a to the 1/3? You said it was the cube root. Well, yeah, that makes sense because the n goes to the index and the m becomes the exponent here. Okay, so we kind of already prepped for it. So all we're going to be doing is rewriting them. So technically the m is that exponent and the n is your index. So here we go. Let's rewrite them. We already did A in a way. How would I rewrite x to the 1/3? How would I rewrite x to the 1/3?
X to the cube root of 5.
The cube root of x. Good. And you can put that 1 there if it helps you just remember that the 1 goes there.
We did this last.
You should have, yes. Well, how do we rewrite b?
2, 7.
Careful.
Root
Yeah, the
Y
square root
of y.
of y to the 7. Okay, if it helps you to put a 2 here, you can. Just know that most likely there will not be that 2 there on anything that you see when we give it to you or any other college or SAT gives it to you. There probably will not be a 2 there. How would I rewrite C?
Like 4 and then a radical of 27. Or,
Yeah, or we can just say
Good job with it.
for C, yeah, 3 cubed, which is 27. We could rewrite it as the 4th root of 27. Okay, you're just going back and forth. The bottom, the denominator becomes the index. The numerator becomes the power or the exponent. And that makes sense, right? Okay, if I have something to the 7th power, it should be up. It should be up in the exponent. Okay.
Always think the numerator is above the denominator. Your exponent is above your index. If you need to kind of visualize it, the exponent is always higher than your index, just like the numerator is above your denominator.
Very good. Okay, we always do D, so we're going to do E. How would I rewrite E?
Square root of 4 to the 3rd power.
Very good. Square root 4 to the 3rd power. Do you have questions on how we rewrote that? Now, technically, again, if you're getting like, whoa, why is there no 2 here? There really is one.
It's just magic.
You can't see it most of the time when we do these. Now, we can simplify this. There's 2 ways to do it. You can either say that 4 cubed is 64, and you know what the square root of 64 is. Or you can say, what's the square root of 4? 2, and then what's 2 cubed? 8. So either way works. You can either say that the 4 cubed is 64, and the square root of 64 is 8. Or you could take the square root of 4 and keep the 3 there, and that's how you get 8 too. There's 2 ways you could have done that.
Do you need the radical on there or no?
You do not, because when you take the square root of 64, you just get 8. Okay, let's go to F. All right, here's where it gets a little tricky. So make sure that you're looking, yes.
The radical?
You could do either or. It doesn't matter. Nope. Okay, so here's something to make sure that you note. You need to be looking at your denominators to make sure they're the same to do this. If they're the same, they all go under the cube root. So then I would have, I'm going to use the different highlighter here, u squared underneath, and I would have w to the 5th underneath. Okay? All right, now I'm going to go the opposite direction, then give you some time to work on your homework. A lot of people were able to finish, or at least get almost finished before they left, even with only 5 minutes left. Go reverse. Is this 4 as the index, is that going to be my numerator or my denominator in my exponent?
Denominator.
The denominator, good. And what goes on the numerator?
3.
The 3. Beautiful. Again, the more you do it, the better. Okay, that's where it's coming if you're a visual person and like highlighters. Okay, what technically does this z have? 1, so how would I rewrite that? Oh my God. Okay. Let's do a different one.
Y to the 1/2.
Yep, it's y to the 1/2. Very good. It's not y to the 1 over 1. It's y to the 1/2. Okay, let's do one that we can kind of simplify a little bit further.
64 to the 2/6, then the 1/3.
Good, 64 to the 2 over 6,
And then it'll equal 4.
which is technically 64 to the 1/3, which is 4, because the cube root of 64 is 4. And that's how we got that. All right. I think we're going to do one more and then we're ready. One more. Let's do a challenging one because I know that this class is ready for it. It's not really challenging, but where does this 3 go? Of all of them, I am so happy that you just said that. Okay, so I get a squared over 3, b to the 4th over 3, and c to the 5th over 3. And you're done. All right, homework's coming.
Wow, long day.